Greetings, students. I hope you're doing well. This is a background lecture on René Descartes, his historical significance, and the times in which he lived, and some of the times prior to that, as a matter of fact. This is not a lecture on any particular text that he wrote. We've already had a lecture on the first two parts of the discourse on the method, and I will post a separate lecture on the first two meditations. Okay, so this is background information, but it's very important to the course. René Descartes lived from 1596 to 1650. He was born in the Touraine region of France in a town called Le Hay. It has since been renamed Descartes, so we could certainly say Descartes was born in Descartes, but that is a bit anachronistic. Because Descartes died in 1650, he's not part of the Enlightenment. He shows up at the tail end of the Renaissance, we might say. That seems like the safest thing to say. So the Renaissance, as you probably know, involved the recuperation, the resurrection of ancient texts, ancient Greek and Latin texts, right? And so as part of that recuperation of the texts, ancient philosophy became important again, right? Christianity had been in ascendance for a long time, and now pagan philosophy, pre-Christian philosophy, was important again, right? And so Descartes and some of the people surrounding Descartes and some of the people who came after Descartes and responded to him, they were in conversation, let's say, with ancient Greek philosophy and ancient Latin philosophy, but especially the Greek figures. Why is Descartes so important? He's considered the founder or the father of modern philosophy. There are different reasons for that. It's partly because he takes the mind so seriously, and we're still trying to understand the mind and understand consciousness and understand how these fit into a scientific worldview, and that is one of Descartes' main interests. So he's still often treated as someone with views worth considering in contemporary debates, right? We don't just write about Descartes in a historical way. We write about how seriously we should take some of his views. We argue, we philosophers, we argue seriously about whether he was correct to make the mind and the body radically distinct, or if there's a view that has some of the benefits of that view, but not all the drawbacks. And then, of course, what the benefits and drawbacks are is something that we'll have to see when we get into the meditations. Descartes is supposed to have broken with the scholastic tradition that began in the Middle Ages, right? And of course, that tradition was a Christian tradition. So philosophy was beholden to Christianity during the Middle Ages, let's say, and scholasticism was part of that. Okay, but we'll talk more about scholasticism in the slides that follow. Descartes is a key architect of the scientific method. We've already discussed his book, Discourse on the Method. Some of the things he says about method are still generally taken to be legitimate, right? So he's an important contributor to the scientific method, and he made important contributions to science and mathematics. So beyond method, he actually discovered things in science that are of interest, and also in mathematics. Okay, what is scholasticism? The scholastic tradition involves a heavy reliance on a fixed canon of works. It rewards, or it rewarded, continuity with the fixed canon. It rewarded mere commentary on the fixed canon. And as it says on the slide, we can't really talk about scholasticism, I don't think, without exaggerating a bit. Of course, there was creativity in the Middle Ages. Humans are a creative bunch, right? And of course, there was some progress on specific problems. So it's an exaggeration to say that people weren't creative and all they did was comment on old works. But that does give you a flavor of what scholasticism was about, right? It was beholden to old ancient works, so that needs to be explained. So let's think about that. There were two key architects of the scholastic period. Aristotle lived from 384 to 322 BCE. That was a long time ago, right? BCE, that's before the current era or before Christ, right? Aristotle was a key student of Plato, and he had his own take on the forms. The forms play an important role in Aristotle's metaphysics, but the forms aren't separate from the world in which physical things exist, right? Plato famously, maybe it's a caricature, but famously Plato thought the forms were separable, so maybe they existed in some ideal realm. Aristotle thought they existed in the physical world, so he's more of an empiricist than Plato, right? So he's a little bit, from our standards, he's a little bit more scientific than Plato, we could say. Now, Aristotle's works disappeared from the Western world after Rome fell, which was in the 400s AD, right? But then, the Islamic world came into existence starting in the 600s and the 700s, somewhere around there. And Muslims, or the Islamic world, they were very interested in ancient philosophy, and particularly they were interested in Aristotle. So there was a lot of Aristotle scholarship in the Islamic world, which was growing in the 800s, 900s, going into 1000, right? So Aristotle's works disappeared from the Western world, from Western Europe, but then at the same time they were circulating in the Islamic world, and then of course certain Muslim groups were coming into Europe and fighting the Christians and so on, and so eventually peace is established in various places. There's a sort of stalemate. The Islamic Empire quits growing. We could have a long historical lecture there, but there's no point, right? Eventually there's peace, there's communication, and so these Aristotelian texts are able to move westward, right? So it's interesting, they're moving into the West in Arabic, right? But eventually the Greek texts, which are in Byzantium, which is also the Eastern Roman Empire, they flow westward as well. So Thomas Aquinas lived from 1225 to 1274 AD. He was an Italian Dominican friar, okay, and a philosopher and a theologian. He encountered Aristotle in Arabic originally, right, and had to work with these Arabic texts. In any case, he was very impressed with Aristotle. He built, or you could say he rebuilt, Catholic theology on Aristotelian foundations, right? So Catholic theology was placed on Aristotelian philosophy. That was the foundation of Catholicism from Aquinas' point of view, right? So Aquinas synthesized Christianity with what we could call a high point of pagan science. I mean, that's what Aristotle's work was. It was a bunch of volumes presenting pagan science, or at least a certain version of it, right? And so this is a weird mix. Christianity resting on pagan science. Despite it being a weird mix, it caught on. Aquinas was declared a doctor of the church, and that meant that what he said was true. It had the official stamp of the church on it. So the Catholic Church was saying, hey, Aquinas' works, these are officially correct. This is the church's viewpoint, right? So Aquinas said Catholic theology rests on Aristotelian philosophy, and then the Catholic Church said, yeah, that's right. Officially, that's the correct view, right? So as a result, Aristotle's philosophy had a near canonical status. So you couldn't really say Aristotle's works were themselves canonical because they were pagan, right? They weren't Christian, so that can't be the correct view. And yet, Aristotle was very important to the church, and the church made sure that Aristotle was taught in Christian universities in Europe in the Middle Ages. And then importantly for our story, Aristotle rejects the mathematical view of nature that was developed by the Pythagoreans in the ancient Greek world, and this mathematical view was espoused by Plato in the dialogue Timaeus, especially. I mean, it's espoused elsewhere in Plato, but especially in the Timaeus, right? So Aristotle's view of science is that it should be qualitative, not quantitative, and that is not an accident. It's not that it didn't occur to Aristotle that science could be mathematical. He had the example of Plato, right, and the Pythagoreans, and he said, no, that is not the way to do science, right? So that sets up a struggle, right? So there's a sort of mathematical science coming along near the end of the Renaissance, but the Catholic Church is committed to Aristotelianism, which says, let's do science in a qualitative way. Okay, so now we know where the struggle is, or that's part of it at least. All right, Descartes' break with the scholastic tradition. Here's more of the struggle. Aristotle's view of the universe is that it is geocentric, meaning the Earth is at the center. This wasn't the view of everyone in ancient Greece. So again, it's not that it never occurred to Aristotle that the sun might be at the center. He believed the reasons for placing the Earth at the center were conclusive, right? So that was the view. He's very committed to it, right? And then since Aristotle had a geocentric view, so did Aquinas, right? And Aquinas was a doctor of the church, and so that was the Catholic Church's view, that the Earth is at the center of the universe. Okay, but there was trouble on the horizon. So Nicolaus Copernicus lived from 1473 to 1543. That's squarely in the Renaissance, right? Copernicus is aware that not everyone in the ancient world thought the Earth was at the center of the universe, right? And so that's in his mind that that maybe that's not necessarily true, or at least once he gets enough training, he's aware that that's not necessarily true. He was born and died in Royal Prussia, which belongs to the Kingdom of Poland, or it did anyway when it existed. So through really careful observation of the stars and the planets, and through quantitative analysis, trying to figure out, how to predict mathematically which star is going to be where, which planet is going to be where at any given time, Copernicus came to believe in a heliocentric view of the universe. He came to believe that the sun is at the center, right? He knew this was a problem. He knew the Catholic Church wouldn't like it, so he arranged to have his great work he worked on for many years. It's called On the Revolutions. He arranged to have it published posthumously. In other words, after he died. He didn't want to be around to deal with it after his work came out. All right, Galileo Galilei. I'm sure you've heard of Galileo and Copernicus, actually. Galileo lived from 1564 to 1642. We're still in the Renaissance, but getting near the end. Galileo was influenced by Copernicus, and also, of course, he read Plato on his own, so he was influenced by Plato's quantitative approach. And Galileo believed that experiments were needed to uncover the truth about the physical world, right? And you have probably this notion of Galileo as being an experimentalist, right? Dropping things from the Tower of Pisa. I mean, who knows whether that happened, but he definitely did experiments. And through his experimentation, he discovered the uniform acceleration of falling bodies, right? Meaning, what do we mean by the uniform acceleration of falling bodies? Meaning they accelerate at the same rate as they fall. At least they do if you ignore air resistance or wind resistance, either one. Right, so he figured that out through experimentation, and he described it mathematically. So the mathematical description that he was using is d for distance equals 1/2 times a, or in other words acceleration, times t, or in other words time squared. So d equals 1/2 times a times t squared. So he's using this formula. He's making careful observations, and he realizes that a is a constant, roughly, right? There is, of course, the issue of air resistance, as I already said, but he comes to realize that a is the same across different distances and different times and different falling bodies, right? So that's a huge discovery, and it shows the power of experimental science, and it shows the power of a quantitative approach in science at the same time. Okay, and then Galileo, of course, did a lot of different things, and there were other things that he did that supported heliocentrism. So one of the things on the slide, there were others, is that Galileo famously built his own telescope, right? Sort of the first really functioning handheld telescope, although I think that's something historians argue about. So he built a telescope, and he actually observed the 4 biggest suns. Sorry, what am I saying now? He actually observed the 4 biggest moons of Jupiter. He actually was able to document these moons going around Jupiter. They were clearly orbiting Jupiter. Okay, so why is that a big deal? Well, if some celestial bodies are going around Jupiter, then not every celestial body is going around the sun. So that observation all by itself shows you that geocentrism is false, because geocentrism was the view that everything in the universe is going around the earth. Right? That was the view. That was Aristotle's view. That was Aquinas' view. And Galileo made this simple observation of these moons going around Jupiter, and that bit of data all by itself falsified geocentrism. Right? And then, it also suggested the fact that these smaller moons were going around Jupiter, which was a much more massive body. It also suggested that smaller bodies orbit bigger bodies. And many of you may not know, the Greeks were actually able to prove that the sun was much, much larger than the Earth. So that had been established over 1,000 years ago by the time Galileo came along. It was well known, right? So if in the case of Jupiter and its moons, the smaller bodies were orbiting the larger body, couldn't that be generalized? The Earth is smaller than the sun. Shouldn't the Earth be going around the sun? Turns out, yes, you kind of need a theory of gravity to understand why it works that way. Galileo didn't have a theory of gravity. But yeah, he certainly noticed that the smaller bodies were going around the bigger one. Okay, Descartes' break with the scholastic tradition continued. In 1633, something really bad happened to Galileo. The Catholic Church condemned him for espousing a heliocentric view of the universe, right? And so this was a big deal to Descartes. This was very alarming. Galileo may have escaped the death penalty simply because he was old and he was going blind from looking at the sun through his telescope. You might have heard of that before. That is a true story. He didn't know, I guess, that he could go blind by staring at the sun through his telescope. So yeah, he couldn't see very well at the end of his life because of his scientific studies. He was placed under house arrest instead of getting a worse punishment. But Descartes was a much younger man, and so maybe he would have been punished more severely, for espousing heliocentrism. And in 1633, when Galileo was condemned, Descartes was working on a book on physics called The World, or you could translate it as the universe. So he was alarmed and he quit working on The World after Galileo was condemned, and he tried to destroy his work, but he failed, and that sounds odd. But at least the story is he tried to burn his copy of The World, but you have to understand, it would be weird to have only one copy of a book that you're working on when it's, the early 1600s. You can't put the thing on your computer, right? So you're gonna write it out more than once, right? If you don't like what you wrote the first time, you're gonna write another draft. People tended to produce various drafts, right? And Descartes is in correspondence with other people, so he was mailing out chapters of The World to other people and asking them what they thought. And so he tried to burn his copy of The World, but too much of the manuscript had gotten out, and so we have a copy, right, pieced together from various manuscripts. Probably not quite the copy that he burned, but anyway, he did fail to destroy it, but he also stayed out of trouble. Okay. Descartes published his Discourse on the Method in 1637. We've already looked at the discourse, so this is 4 years after Galileo's condemnation. How is it different from The World? Well, it doesn't mention geocentrism or heliocentrism. It focuses on correct method, as you know, because we've read some of it. And that's a more abstract issue, right, than the issue of whether the sun is at the center of the universe or the earth is at the center of the universe. So in a way, Descartes is hiding behind abstractions. I think his interest in method is genuine. I'm not questioning that. But I also think this focus on abstract method is something of a defense strategy. He's trying to avoid controversy by focusing on abstractions. Okay, so then the Meditations on First Philosophy, which was published in 1641, a few years after the Discourse, that is also largely focused on methods. So Descartes sort of stuck to this strategy of focusing on the abstract. The Meditations make some pretty heavy metaphysical claims, but I would say it is largely focused on method. So in the Meditations, Descartes tries to lay a foundation for empirical science without committing himself to controversial scientific claims. He doesn't get into the nature of the solar system. In the world, he had actually speculated about how the solar system might have come into being if God didn't create it. Right, so he did use that if phrasing. Well, if God didn't do it, it could have happened like this. The solar system could have come into being like this, right? It was a just so story. He avoids that kind of thing in the Meditations, right? He's trying to stay out of trouble. Also, the Meditations is dedicated to the theology faculty at the Sorbonne. So it seems like Descartes is sucking up, to be blunt about it. He's treading carefully when it comes to the Catholic Church. That's the nice way to put it, I suppose. Okay, so we've already said Descartes is important. This is a little more concrete with regard to why Descartes is important, right? So, first of all, he created the Cartesian coordinate system. Here's a little graph on the side, right, to remind you, oh, this is the Cartesian coordinate system. This is how you graph y equals 4 minus x squared. You get a nice curve like we see here in the picture. So when Descartes developed the Cartesian coordinate system, this allowed him to bring algebra and geometry together in new ways. He was able to use geometry to solve problems in algebra. He was able to use algebra to solve some problems in geometry, right? And this was all very new. So in a way, the Cartesian coordinate system is a translation device, right? Again, looking at the picture on the right, there's some algebra, y equals 4 minus x squared, and there's a nice geometrical image to go with it. So we're translating from the one to the other. Given that Galileo had already described mathematically how bodies fall to the earth, Descartes, with this coordinate system, gives us the tools to depict the trajectory of a fired cannonball, among other things. But this is important because of the period of time we're in. Cannons are somewhat new, cannonballs are somewhat new. You can use this graphing system to visually depict the trajectory of a cannonball being fired up in the air and then coming back down, right? You could use Galileo's equation to determine where you're going to be on the y-axis, right, as we're going along the x-axis because of the force of the cannon firing the cannonball, right? You analyze problems like these. I don't mean to get into a physics lecture, but as far as traveling along the x-axis goes, that's sort of determined by the velocity as the cannon exits. The velocity as the cannonball exits the cannon, right? That gives you some kind of data about what's going to happen with your x value. But as far as the y value goes, it's going to be largely determined by what Galileo already told us. Well, how do these things fall to the earth, right? Because the cannonball is starting to fall as soon as it comes out of the cannon. That's why you get a curve, right? That's why it doesn't just shoot straight up and keep going. You get a curve because gravity is going to work on it right away. I hope that makes sense. I don't mean to give you a math or physics lecture, but I think this is fascinating stuff, so I hope I'm giving you some bit of insight into it. Okay, so more of Descartes' achievements. He independently discovered the law of refraction. In optics, refraction has to do with the way light bends when it goes from a more dense to a less dense medium, or from a less dense to a more dense medium. It will bend. Descartes described how it bent mathematically in those kinds of cases. Descartes, of course, worked on method, so he provided a way for science to move forward. There was a method, there was a way to proceed. Also, there was an issue about free will, right? We're supposed to have free will. We're supposed to be free to do what we want, but then you look at a cannonball falling to the earth, and it seems like it has to behave in a certain way. It's deterministic, right? Because he made mind and body radically distinct in the Meditations and in the Discourse, Descartes allowed science to proceed, right? Because he's sort of cordoning off the mind and saying, well, it's radically distinct, so the mind can be free, while the physical universe is deterministic. So that also allowed science to move forward. And of course, Descartes argued extensively for the applicability of mathematics to the natural world. That really should be our emphasis here, so I've got it highlighted on the slide. Right, because that's the through line here. That's coming from Copernicus. Well, it's coming from Plato and the Timaeus through Copernicus, through Galileo to Descartes. Descartes is saying, let's do science quantitatively, right? Yes, you can apply mathematics to the natural world. It's okay. So in his Meditations, Descartes argues that the arithmetical and geometrical aspects of the world are the most certain aspects of the world. It's not just that they're applicable, we're more sure of the arithmetical and geometrical aspects of the world than any other aspects, like color, for instance, because the arithmetical and geometrical aspects are the most, they're more and they're the most clear and distinct aspects. They're the most clear and distinct attributes that physical things have, right? We can describe physical things mathematically, and those mathematical descriptions are completely clear and distinct. We already saw in the Discourse that Descartes' first rule of method is go with what you know, and what you know is what's clear and distinct, right? We already saw that in the Discourse, and then Descartes emphasizes what is clear and distinct in the Meditations in a different way, related but somewhat different. Okay. This is our final slide here. I want to say something about the style of Descartes' Meditations on First Philosophy. I guess this is our last full slide, our last complete slide, or last slide with a full array of content on it. Anyway, I want to say something about the style. the Meditations is written in the first person, and we should think about why. I think that's important and significant. It's written in the first person so that it will invite the reader to go through Descartes' own thought processes. So it's very intimate in this respect. Descartes is inviting you into his own mind. He believes it will be more convincing to the reader if he reveals his own intellectual journey. He already mentioned this in the Discourse on the Method. It's clear in the Meditations that he continues to believe that this is the case. Here's how I came to have these beliefs. Let me show you. Let me show you how my mind got from point A to point B. He wants you to follow along. He thinks you're going to find that convincing, right? And yeah, he does suck you in. I think it is convincing. Saint Ignatius of Loyola lived from 1491 to 1556, similar to Copernicus's time frame, right? So Saint Ignatius is the founder of the Society of Jesus. In other words, he's the founder of the Jesuit order, right? And you might recall I'm at Regis, and we're a Jesuit institution. So here's a Regis connection. So Saint Ignatius used a similar style in his work called Spiritual Exercises. So this book is what it sounds like. It's meditations or exercises. You could call them either one. The title says they're exercises. But in this book, Ignatius is inviting you to follow along in the meditative process with him, right? It's intimate, like the Meditations is. He's inviting you into his own thoughts and feelings and attitudes. And so you're supposed to just follow along with his lead, right? And then your faith in Jesus and Catholic doctrine is supposed to become strengthened as you go through the exercises. And Descartes himself uses this pretense that you should go through the Meditations one per day, right? And there are 6 meditations, so it'll take 6 days. It's a pretense. I mean, nobody does that, right? I think Jesuits going through the spiritual exercises have reason to actually go through them one day at a time, because you're supposed to really rest and reflect afterward. It's about faith. It's very personal. But if you're going to read the Meditations, just, read through them at your convenience. There's really no reason to read them one day at a time, or certainly not the same reasons. Okay, so we've talked about historical background, Descartes' achievements. We've talked about the style of the Meditations and what to make of that. And so we are now ready to examine Descartes' Meditations on First Philosophy, right? One of the great works in the history of philosophy. So I'm glad you could work through this background with me. Thank you.